All right, guys, there we got more formulas, double angle, half angle, and product to sum formulas. And there's really one more that's not in there, which is called power reducing, which you will see in a second. So let's just hit these things. Also, before I go there, I'm going to show you like this first slide. Hang on. This first slide has all these formulas for the double angle. Your piece of paper, I'm going to give you an identity page. I already given you one, but we'll add all these on there that are not on there yet and update it some. So don't worry about the memorization as much as just learning how to use the formulas. All right, so there's all the double angles, and like I said, they'll be on your piece of paper. So we'll have all those down for you. That's what they look like. All right, so the first one says, if cosine is negative 2/3 and is in quadrant 2, find cosine 2x and sine 2x. Now, before you can find either one of these, either cosine 2x or sine 2x, you need to have both cosine of x and sine of x. So I know cosine of 2x is negative 2/3. I also need to find out what sine x is right there. So remember, cosine squared plus sine squared is 1. So if I square negative 2/3, I get 4/9 plus sine squared equals 1. If I move that 4/9 over, I get 5/9, and then take the square root, get plus or minus square root of 5 over 3. Now, it tells me it's in quadrant 2. Because it's in quadrant 2 and it's sine is positive. So even though I put plus or minus there, I'm really going to use positive square root of 5 over 3 for sine. Okay, now, got to find two things. Sine 2x and cosine 2x. The formula for sine 2x was 2 sine x cosine x. And now that I know those two values, I'm just going to plug them in. Sine x is negative 2/3. Sorry, that was cosine. I got them mixed up. I'm doing it backwards. And sine x is square root of 5 over 3. Sorry about that. Now just multiply those. If you multiply those, you get negative 4 on 5 over 9. That's sine 2x. All right, to find cosine 2x, you have three options. There were three formulas on that last slide. And on your paper to find cosine 2x, I'm going to do cosine squared minus sine squared. All right, so if I do cosine squared, I will get 4/9. And if I do sine squared, which is right here, by the way, is 5/9, which would give me negative 1/9. And that's cosine 2x. There's my sine 2x, there's my cosine 2x, just using the formula. Next one says write cosine 3x in terms of just cosine x. Now, to do that, we don't have a thing for cosine 3x, but what I can do is I can break the 3x down and do this right here, right? Like cosine 2x plus x. And then I can follow the cosine sum formula that we have, which is cosine minus sine. All right, which gets me close. I have two x's in there still, and it said the direction says right in terms of cosine x only. So cosine 2x is, remember, I'm looking for cosines only. So cosine 2x is 2 cosine squared minus 1. That's on your page, times cosine x. Sine 2x is 2 sine x cosine x times the sine x that's already there. So I'm going to simplify some things and see what I have here. On this first set right here, I'm going to distribute that cosine, make it 2 cosine cubed x minus cosine x. And on the second part, it's really 2 sine squared cosine x. Okay, so I'm done except for this right here. I cannot leave that sine squared in there. So I need you to remember what sine squared really is. Sine squared is really 1 minus cosine squared. So I'm going to change that to 1 minus cosine squared. And I got that cosine x still sitting outside there. So to finish up here, I got 2 cosine cubed x minus cosine x. And now I really have this 2 cosine x. I'm going to distribute both of those at the same time because this is pre-cal. We can do that. 2 cosine x times 1 is 2 cosine x. And if I distribute the 2 cosine x times the cosine squared, I get positive 2 cosine cubed x. So here's what I'm seeing. I see those two terms are like terms. So I have 4 cosine cubed x. And I'm seeing those two terms are like terms. So it's negative 3 cosine x, which is what they wanted. They wanted everything in terms of cosine x. No 2x's, no 3x's, anything like that. That was kind of a doozy. Let's keep going. All right, how you lower powers. there's your, again, these will be on your sheet, how to go from exponents to no exponents, which is what they're going to ask me to do here in just a second. So there they are. Let's do a problem. All right, so this one says, write sine squared cosine squared in terms of the first power of cosine. So I got to get rid of the exponents and get rid of the sine. Let's give it a shot here. And I'm getting this stuff just from the last slide. The last slide told me what sine squared was. Sine squared was 1 minus cosine 2x over 2. And cosine squared said 1 plus cosine 2x over 2. All right, so I'm going to multiply those together. See what I get here. But notice the top are conjugates. And when they're conjugates, you can just do just FL, first, last. So I'm going to get 1 minus cosine, darn it, squared 2x. The reason I said darn it, that just put an exponent back in there, all over 4. So I'm going to break this down now. I'm going to break down that cosine squared. Now, it's cosine squared again. So if I do cosine squared, that's this. Okay, that's what we did second. Notice the cosine x here went to 2x. You always double the angle. So right now I'm starting with a 2x. When I write this here, I'm going to do 1 plus cosine 4x. That's a cosine right there, sorry. It's supposed to say cosine. Over 2. And all that's over 4. Wow, that's a lot of stuff. So let's see if we can simplify that. We can simplify it. Here we go. Let's go do it. All right, so we got 1. Let's do this. What I'm seeing here, because there's let's do this. I'm going to multiply the whole top and whole bottom by 2, because that's going to get rid of the fraction on the top. Remember, no fractions in a fraction. So if I do the whole top by 2, if I do 1 times 2, that's 2. And then the second term, it just takes the fraction away. All right, and on the bottom, 2 times 4 is 8. So I'm one step away, I think, from getting this answer here. I'm just going to get rid of the brackets. And let's go ahead and subtract 2. 2 minus 1 is obviously 1. So I'm going to go 1 plus cosine 4x over 8. And there you have it. Okay, kind of a weird answer. You got to kind of keep working through there, but you can do it. All right, last thing, half angle formulas. Half angle formulas, again, these are on your paper, on your formula, or on your identity page. And there's one for sine, there's one for cosine, there's one for tangent. And this is big down here. The choice of the sine depends on what you divided by 2 is. The original angle. Depends on where the original angle is. Now, let me show you what I'm talking about here on this next slide. Okay, it says find the exact value of sine 22.5 degrees. Obviously, we don't know what the exact value is. That's not one that's in our chart, on our unit circle. But the cool thing about 22.5 is, sorry, I had to have a drink there, is it's half of 45. So what the half angle formula says you can do is you can write it like this. You can say, well, 22.5 is really 45 divided by 2. And what I'm going to do then is I'm going to follow the half angle formula for sine, which looks like this. Plus or minus the square root. This is on the last slide on your paper. 1 minus cosine 45 degrees over 2. All right, so I'm going to go through here and try to simplify that. First of all, the plus or minus. Sine 22, that's what I'm talking about. The original angle, 22.5 degrees, is in quadrant 1. Everything's positive in quadrant 1, so I know it's going to be positive. All right, so I also know that cosine 45 degrees is square root of 2 over 2, and you know that as well. All over 2. Now, we would be done, except you're not allowed to leave that fraction inside a fraction. No fractions in a fraction. So I'm going to do what I did a second ago. I'm going to multiply the whole top by 2, the whole numerator, and the whole denominator by 2. And what happens is my numerator becomes 2 minus, this one the 2's cancel, it gives me square root of 2. My denominator becomes 2 times 2 is 4. And again, I would be done, except for one thing I noticed, and that is I can't take the square root of the top. I'm kind of stuck with the top. But I do know what the square root of 4 is in my denominator. So I'm going to end up right here. I'm going to have a square root on the top with 2 minus the square root of 2 inside. The bottom is going to have 2 because that's the square root of 4. And there you have it. That's the exact value. If you punched this in right here, sine 22.5 degrees in your calculator, you're going to get some decimal, which is an approximation. But if you punch this in your calculator also, you would get the same decimal. But this is the exact value because that's no decimal at all. Your calculator kind of rounds a decimal at the end. That's why it's called exact value. All right, guys, I know that's a lot of stuff. Sorry for the length of the video. It's good for you to have these, though, before Friday. I'd probably watch this one again so you can see some examples of stuff worked out. But it's all about just following those formulas on your identity or formula page, okay? It's all about. So see you in class tomorrow. See you, bye.